Hello everyone, welcome back to week 10 video for CS4540. So for this week, we'll be doing something different where I'll be showing 3 clips for the first half of the video, and for the second half, we'll be attempting this ARC problem that my professor has posted in real time. So for the first clip, we have general intelligence, ARC AGI dataset, and then the second clip, we have generative AI foundations, neural networks, mirror brain, and general intelligence ChatGPT plus ARC equals to AGI.
To fulfill these requirements for a good benchmark of intelligence, I've put together a data set. It's called the Abstraction and Reasoning Corpus for Artificial General Intelligence, or ARC-AGI for short. And you can think of it as a kind of IQ test. So it's kind of intelligence test that can be taken by humans. It's actually very easy for humans, or AI agents. And you can think of it as a program synthesis data set as well. So a key idea is that in ARC-AGI, every task that you see, every task you get is novel. It's different from any other task in the dataset. It's also different from anything you may find online, for instance. So you cannot prepare in advance for ARC. You cannot just solve ARC by memorizing the solutions in advance. That just doesn't work. And ARC tries to control for experience because you're doing few-shot program learning. You're seeing, 2 or 3.
What really stuck with me from this clip is when the professor asked, how can I write a program to solve this problem? That question hit at the heart of what makes ARC abstraction and reasoning corpus so interesting to me. Each problem is different. There's no single algorithm that can solve them all. You have to reason, abstract, and recognize patterns in very human ways. That's where AI comes in, but not just any AI. Most AI systems today are great at picking up on a statistical pattern across tons of data, but ARC isn't about repetition, it's about flexible reasoning. It's it's the kind of thing we humans find intuitive, like understanding symmetry, spatial relationships, or what comes next. But it's exactly the kind of thing most traditional programs struggle with. It really makes you think about how far we've come with AI and how far we still have to go before machines can reason the way we do. ARC feels like a benchmark for human level abstraction, and I think it's one of the most exciting challenges in AI right now.
Participant. From the model, you get unit activations, and from the brain, responses in the language areas. And then using these 2 sets of numbers, you basically compute a similarity metric. Using this approach, we compared representations from 43 language models, so these are off-the-shelf models, against human brain responses. On the y-axis, I'll show you how similar each model's representations are to human neural responses in the language system. And each bar here is a model. The majority are transformers. And here's what we found. As you can see, models vary quite a lot, but some models do really well in capturing human neural responses. So at least for some models, the representations of linguistic input are in some way similar to those of humans. Importantly, remember, these models were not built to mimic the human brain. They were simply built by engineers to do a task, predicting the next word in a piece of natural text. Yet somehow they end up with a representational space that resembles that of humans. And this result has now been replicated by several independent groups. So having established this representational similarity.
What I really found interesting in this clip is the idea that large language models like GPT are structured in a way that actually resemble the neural networks of the human brain. That parallel is fascinating because it suggests we're not just building tools that process data, but systems that mirror how we as humans think and learn. It makes sense why these models are so powerful. They're tapping into architecture that's inspired by our own cognition. And while they're obviously not conscious or sentient, the fact that their structure and learning patterns have this resemblance to human neurons opens up a lot of questions about how intelligence works, both artificial and biological. This kind of insight also makes me appreciate how far AI has come, not just in terms of performance, but in how closely it's starting to align with our understanding of the brain. It's not just about output, it's about how that output is generated through layered reasoning and pattern recognition.
Is the submission from Ryan Greenblatt on the ARC-AGI AGI leaderboard, the public leaderboard. So it's using a very sophisticated prompting pipeline based on GPT-4o, where it uses GPT-4o to generate candidate Python programs to solve our tasks. And then he has an external verifier. It's generating like thousands of tasks thousands of programs per task. It also has a way to refine tasks, programs that seem to be doing, close to what you want. So this scores 42% on the public leaderboard, and that's the current state of the art. So again, here's where we are. We know that LLMs fall short of AGI. They're great at system one thinking, they lack system two. And meanwhile, progress towards system two has stalled. Progress towards AGI has stalled. The limitations that we are dealing with
What really caught my attention in this clip is the question, if GPT can solve ARC, does that mean we've reached AGI? That's a powerful idea. ARC isn't just a set of puzzles, it's a test of abstraction, reasoning, flexibility, and generalization. So if a model like ChatGPT could consistently solve ARC tasks, that would suggest it has that go way beyond pattern matching. It could mean it's capable of true reasoning. It's interesting that the lecture chose to include this point because AGI, artificial generated intelligence, means an AI that can think, learn, and solve problems across a wide range of domains without human guidance. It would be self-sufficient in learning new tasks, much like a human. Including this question in the lecture really drives home how important ARC is, not just a challenge, but as a milestone. It represents a kind of benchmark. If AI can handle ARC on its own, maybe we are closer to AGI than we think. So we're starting the second half of the video. This is the ARC problem that our professor has chosen. One of the ARC problems that my professor has chosen for us. I haven't had a chance to look at it, so we'll be solving this in real time. So let's get into it. So looking at the first example, it looks like the color on the inside. The reasonings. I'm gonna be explaining my reasoning while I'm trying to solve this problem. So I'm thinking is the colors bridge to another color, and then the bridge is the color of the middle square. So that's what I'm getting at right now. And there's squares at the bottom. I wonder if they're connected. Maybe that's a hint. So the second one does the same thing, but now it goes to the right. So I'm thinking, why does it go down for this one, but go to right for this one? Interesting, interesting. Let's start off with the replicating this part. Let's see. 29 by 29. Copy for input. Okay. Let's see. Oh, I think I'm kind of getting it. I think that the color at the bottom shows the sequence of how you're supposed to connect it, and that looks about right. So let's see, yellow connects to light blue. Yellow connects to light blue, okay. And then light blue connects to dark brown. Okay, let's see what dark brown connects to. It connects to yellow. And then yellow connects to orange. Ooh, hold on. Are we messing up? Okay. And then yellow. And then orange connects to pink. Pink connects to this dark brown one. And then dark red, or this dark brown one connects to the yellow, I believe. Yes, and then yellow connects to gray. Gray connects to green. And then green connects to orange. Let's see if we solved it. This is pretty fun. And yes, we have solved it. So from one of my professor's ARC problems that he picked out, I decided to press next and then do another let's solve together. So looking at this one, it does look very complicated. I'm trying to see if I can recognize a pattern. It looks like they're making stacks. Oh, it looks like the color gray connects to a color and then goes up. Let's try the hypothesis. I'm thinking like how would I make an AI or like a computer program to recognize this? This is pretty intense. Like okay, so I'm guessing this gray one, this gray one would keep going up until it hit this blue one, and then this blue one will keep going. And maybe like this. And, I think this is the answer. Let's submit it and see. Yes, we got it. We got it, guys. The three clips. I decided to do another ARC puzzle. So for so let's get started on this one. This is from the hard set. So it seems like this one is recognizing the pattern. I think that you're supposed to fill in and keep the pattern going for each of them. Just copy from input. So I think this one is missing a red. So there's a red right here. Let's see. So this is a little ladder. I think it wants us to keep continuing. So blue should be here. I think this one is supposed to be like that. So it continues. It continues the little zigzag. Let's see this one. Blue, blue. I think it wants that. I think it wants us to, yeah, complete this. There we go. See if there's anything missing. There's nothing missing. Okay, let's see the last one. Okay, I think they want us to fix these. Let's see. All right, we made the patterns. Let's see if it's the right solution, and it is. Well, that's all I have for you guys for this week. I hope you guys enjoyed the video. I'll see you next time.